Hey guys, welcome back. I thought I'd just tag this little intro onto the start of my superposition video today, just to say I hope you had a good Easter. I hope you managed to keep things ticking over by doing the work and you didn't leave it all till too last minute. Maybe you had a bit of chance to just chill out, and that is essential. As you will have seen if you read that soppy email that I left over Easter holidays, you guys did such a good job, like way better than I expected, in getting into the routine. Once you left college, pretty much everyone was there and on board. It's so important that you don't let Easter get in the way of that and stop that routine. You'll find now that it's really hard because you've just had a holiday, you've just been lying in and having some chill time. You might not have been doing work every day, and you're about to discover how challenging it can be working at home to get back into a routine. It's really, really hard. Super important that you do though, okay? Have that space set up to study, get in that mindset. If you can't do it right now, go and have a shower, go and have a walk, do something that's gonna just wake you up a bit, have a coffee if you're that kind of person, and then sit and pick a task, set goals for yourself, fill in the book, watch the videos. The topics that we're looking at now, they do get quite advanced for waves. Usually we would have done loads of recap. Remember that the great thing about remote teaching, one thing I really like about it, is you can go back and re-watch old videos, go back to the list. If I'm talking about phase difference today, which I will be, then you're not sure what it means, then go back and look at the phase difference video. If I'm talking about something to do with polarization, look it up again. All of those videos are there. In a way, it's probably better than a normal lesson because you can rewind and play back what I've just said without having to put your hand up and ask. You can just pause, look back, review, go over things. It's important that you do that if you are feeling unsure about a topic. So remember that everything that we do as well is to try and get ourselves ahead of others, to keep us at the top of the grade boundaries, to make sure that we're being super competitive here. If we weren't working now, we would lose so much time next year. And if you guys are cutting corners by just copying in the answers, just copying the books, you're doing yourself a disservice. I've got my physics degree. I don't need to make you do the questions in order to get you a top grade. You need to do the questions for yourself. And if you're struggling with it, ask, get in touch with us. Anyway, have a quick try of this recap and then we will jump straight into superposition. Remember the most important thing, if you've got any questions, I will not be walking around your house and discovering that you've got a problem. You need to get in touch with me. And I've had some great chats over the Easter holidays with people who've got in touch then, even now especially. These topics especially, if you don't understand, if you're not sure, if you want a recap, just ask. I would consider all of the booklets that we've done so far to be the basics of waves. 4.10, how do we measure waves? What are their properties? 4.11, what do waves do? How do they interact with things? They refract, diffract, they can be polarised. The EM spectrum, that's easy as GCSE physics. And refraction. Refraction is a big, meaty book. Make sure you are really good at it, because I know that year 13, even up till January time, year 13 still forgot how to do refraction. Don't make that mistake. Practice it and make sure you can do it. This book starts the more advanced ideas in waves. Superposition, interference, diffraction patterns. It starts out really just asking a simple question. What happens when two waves interact with each other? One going this way, one going that way. What happens when they interact? When two or more waves interact, we say that they interfere. Interference is when two waves superpose and there's a change in overall displacement. Interference is governed by the principle of superposition. The principle of superposition states that when two waves interfere at a point, the resultant displacement is the sum of the individual displacements. So add up the displacements and that includes negative displacements. They will subtract from the total value. So we can get areas where the wave displacements add up, we can get areas where the wave displacements subtract. So try it for that example in your book. If you've just copied it in, get a blank piece of paper out and see if you can point by point sketch that wave by adding up the individual displacements, join them with a smooth curve. So when I take the two waves in the book that look like this, when we add them together, we actually get this really weird shape. And it doesn't matter that it doesn't look like a normal wave, because this is two waves interacting. This is a superposed system. What matters is that I've added up these and got the resultant displacement. I've added up these and got a resultant displacement. Where this is negative, that cancels off with that, so I get a lower displacement. Where they're both 0, it's 0. So I recommend going through point by point, add them up, 0, add them up, get a maximum, add them up, one cancels off a bit, add them up, and just sketch point by point that wave and join it with a smooth curve. This can result in some interesting wave shapes that aren't completely sinusoidal. That is fine, that's kind of the point here. I have some other tasks here and I'm going to use these for you to have a go at. So get yourself a blank sheet of paper and see if you can sketch the resultant of these waves. I've put on the amplitude of each one here. The amplitude of the green wave is 3, the amplitude of the black wave is 10, and they have the same wavelength in this case. You'll notice that they add up. If you add point by point, you just get a larger wave of the same frequency. This is called constructive interference. If two waves of the same wavelength add up and you get a bigger version, it's constructively interfering. It's just making a larger version of that wave. Try this example. It's not a trick question, but you'll get it. In this case, the displacements will cancel off to 0. And actually, even though there's two waves passing through, the superposition of these two waves gives us a flat 0 line, and it's almost as if there's nothing there at all. This is really, really interesting, and it's a consequence of so many things as a consequence of this happening. This is called destructive interference. The two waves interact and superpose to form no wave. They cancel each other out. Destructive interference and constructive interference are critical effects that you must know about. Now, normally at this time we'd be spending a lot of time looking back on the previous books. I'm worried that you might not do that at home and you might just keep pressing on. So here's a quick standard answer mini test quiz for you to have a go at. See if you can answer this without looking at your notes. And then I'll give you the answers at the start of the next video.